Hello, my dear friends. How are you all? I hope you all are fine. So, my dear friends, you are very welcome in a lecture number 4 of number system. Okay. So now, my dear friends, I hope you will enjoy this lecture. So, without wasting the time, let's start. Yes. So today we are going to discuss a very amazing topic, which is decimal expansion of real number. What is? Yes, decimal expansion of real number. So, my dear friends, what is decimal expansion? What is decimal expansion? So my dear friend, this is the conversion of fraction into decimal. Simple. I hope you understand these things. Okay, so basically it is the conversion of fraction into decimal form. Into what? Decimal form. So my dear friends, after converting it, once the real number is converted into the decimal number, then it is easy to represent on the number line. First thing is that, okay, and this is easy to identify that this is rational numbers or irrational numbers. This is rational numbers or irrational numbers. So my dear friends, there are two cases when we convert the fraction into the rational number. Then there are two cases. What are these cases? So the first case is like, first case is that the remainder become 0. The remainder become 0. And second is the remainder not become 0. Not become 0. Okay. Yes. So now, my dear friends, on the basis of these two conditions, we can identify that the number is rational number or irrational number. How we can find it? Let's see that. Yes, here is the chart of decimal expansion. So there are two conditions, which is when the number is terminating. When the number is terminating means let's suppose 2.5. This is what? This is terminating numbers. In this case, the remainder becomes 0. In this case, the remainder becomes 0. Okay. So that type of numbers are what? That type of numbers are rational numbers. That type of numbers are rational numbers. So my dear friends, we can say that if the decimal expansion of any number is terminating, then we can say that this is what? Rational number. Or we can say that the decimal expansion of rational number is always terminating. Now the second case is that, now in the case of non-terminating, there is again two categories. What? So my dear friend, the first category is after decimal point the number is repeating. After decimal point the number is repeating, like 2.3333 and so on. This is not terminating, but the number is repeating after the decimal point. So we can say that this number is what? This number is rational number. So we can say that the decimal expansion of terminating number and non-terminating non-repeating number are the rational numbers. Or we can say that the decimal expansion of rational number is always terminating and non-terminating repeating. Okay, I hope you get this point. Now the second case in non-terminating is that non-repeating, means after the decimal point the numbers is not repeating, means the number is unique and non-terminating. Okay, let's suppose 2.5632456378 and so on. So my dear friends, in this case, after the decimal point the numbers are not repeating. The numbers are not repeating. So we can say that the decimal expansion of the number is, if the decimal expansion of the number is non-terminating and non-repeating, then we can say that the number is what? The number is irrational number. I hope, my dear friend, you understand these things. Or we can say that the decimal expansion of irrational number is always non-terminating and non-repeating. I hope, my dear friend, you understand these things. So this is the identification of the rational numbers and irrational number with the help of decimal expansion. With the help of what? Decimal expansion. So my dear friend, this is very easy to understand. To understand that the number is rational or irrational if if we convert the fraction into the decimal form. If we convert into the fraction into the decimal form, how we can convert it? We can easily convert it by the long division method. We can divide with the simply method. Okay, I hope you understand these things. Okay, so now let's move on. So here we are going to discuss rational number to decimal. Now here we are going to convert the fraction of rational numbers into the decimal form. Okay, how we can convert it? So my dear friends, so the case one is when the remainder is equals to 0. Okay, when the remainder is equals to 0. Let's suppose we have an example like 3 upon 6. Okay, now we have to find the decimal expansion of 3 upon 6. How we can find it? So my dear friends, we are doing the simple division, like here is 3 and we have to divide by 6. Okay, so now in this case, this number is less than this number, this less than the 6. Okay, so here is, my dear friends, dividend is less than the divisor. So in this case, my dear friends, we are taking the point and here is 0. So now this will become, my dear friends, here is, if we solve this, how many times it can goes? So 5 times, so we have 30. So this will become, my dear friends, 0.5. So the decimal expansion of 3 upon 6 is what? 0.5. Okay, I hope you get this one. So my dear friend, this is the decimal expansion of rational numbers when the remainder becomes 0. When the remainder becomes 0. Okay, now my dear friends, second case is remainder not equals to 0. Now in this case we have the remainder is not equals to 0. For example, let's suppose we are taking 5 upon 13. Okay, we have to divide this. Now let's divide 5 divided by 13. Here is again dividend is less than 2 divisor, so we have to take the point, so this will become 0. Now here is, we know that 13 3s are 39. Okay, so this will become 11 and there is 0. Now again 13 8s are 104. Now if we subtract, we get 6. Okay, now there is 0. Now again here is 13 4s are 52. 13 4s are 52. So my dear friends, we get here is 8. There is 0. Now here is 13 6 are 78. So we get 2. Okay, now here is 0. Okay, yes, so now 13 ones are 13. So here is we are writing here. Okay, so there is 20. So 13 ones are 13 and if we subtract this, we get 7. Again we are writing 0. Okay, okay, and we know that 13 5s are 65 and if we subtract 70 to if we subtract 65 from 70, we get 5. We get what? Yes, we get 5. And again here is 0. Okay, I hope you understand these things, my dear friends. Now 13 3s are, here is 13 3s are 39 and if we subtract 39 from 50, we get 11. Okay, and here is 0. Now if you observe this, the digits will be repeats here after this. So now here is, you can see that 13 8s are 104. Okay, and we get 60. Okay, now after that you can observe this, after the 5 digits, after these digits, the digits will be repeated. So these steps will be continued. Okay, I hope you understand these things. So we can write here as 5 upon 13 is what? 0.38461538 and so on. Okay, so we can write it as like 0.384615 and bar. Okay, we can write here like this. Okay, it means after the 5 the digits will be repeated. Okay, so now here, okay, so here we can say that the decimal expansion of, yeah, the decimal expansion of rational number is non-terminating and repeating. Okay, I hope you get this point, my dear friends. So now, my dear friends, here we are going to expressing decimal numbers as our rational numbers. Okay, now my dear friends, here we are going to convert the decimal forms into the rational forms, means into the fraction form. Okay, so now case 1 is when the decimal number is terminating decimals. When the decimal numbers are what? Terminating decimals. Let's suppose, for example, we have 0.625. Okay, and we have to convert it into the rational number. How we can convert it? Now, first of all, let x is equals to 0.625. X is equals to 0.625. So now, my dear friends, okay, so now, my dear friends, after writing this x is equals to 0.625, we have to see the number of digits after the points, after the decimal. Okay, so now, my dear friends, here is after the decimal, here is 3 digits. Here is what? 3 digits. So now we have to multiply 1000 in the numerator and in the denominator also. In the numerator and in the denominator also. So now this will become, my dear friends, here is, if we remove this, so we get what? We get 1000. Okay, and here is, if we divide this, then this will be cancelled. So we get 625 divided by 1000. 625 divided by 1000. Okay, now we have to simplify this, means we have to convert it into the simplest form. After converting it into the simplest form, this will become, my dear friends, 5 upon 8. Okay, 5 upon 8. How we can convert it? So now this is very simple, my dear friends. We have to divide by the least number. This will be cancelled by the 5 how many times? 1, 2 and 5. And this will be cancelled by 5 how many times? 2, 0, 0. Now again this will be cancelled by 5 how many times? 2 and 5. And this will be cancelled by this 40 times. Okay, and this will be cancelled by 5 times, and this will be cancelled by 5 by 8 times. So we get 5 upon 8. So this is the simplest form. This is what? This is the simplest form. Okay, I hope you understand these things. Okay, so here we are converting 0.625 into the 5 upon 8, means into the rational number. So this is our answer. I hope, my dear friend, you understand these things, how to convert the decimals into the rational number if the decimal is repeating decimals. Okay, now the second case is that when it is recurring decimal, means when it is a repeating decimal, non-terminating and repeating decimals. Okay, so now in this case, let's suppose we have to take an example like 1.042 bar, means this 42 is repeating again and again and again. Okay, means this is like 1.042424242 and so on. Okay, and we can write it as like 1.042 bar. This is bar, means this is repeating again and again. I hope you understand this thing. So now again, let x is equals to 1.042 bar. Okay, I hope you get this point. So now, my dear friends, Okay, so this is our equation number 1. So now my dear friends, after this writing x is equals to 1.042 bar, we have to see that how many numbers are repeating after the decimal. How many numbers are repeating? So only two numbers are repeating. Only what? Only two numbers are repeating. So now my dear friends, we have to multiply. We have to multiply both the side in 100 because two numbers are repeating, so we have to multiply 100 because in 100 there is two zeros. Okay, so now this will become, my dear friends, 100x is equals to, this will become 104.2424 and so on, 2424 and so on. So we can write it as like 100x is equals to 104.242 bar, 242 bar. So this is our second equation. This is our what? This is our second equation. Now after this, subtract equation 1 from equation second. So we get, my dear friends, here is, if we subtract it, we get 100x minus x, which is equals to 104.242 bar minus 1.042 bar. Okay, so after subtracting this, we get, here is 99x is equals to, and 104 minus 1, this will get 103 point. Here is this 2 is as it is, and after rest of the number will be cancelled, will be 0. So this will become 103.2. So now my dear friend, this will become x is equals to 103.2 divided by 99. Okay, now if we remove this point, this decimal, we get 10 in the denominator. So this will is equals to 1032 divided by 990. Yes, so now my dear friends, now we have to reduce it into the simplest form. Okay, so if we cancel 8 by 2, we get 5 1 6. Okay, we get what? 5 1 6. Now if we cancel this, we get, if we have to divide it by 2, so we get 4 9 5, 4 9 5. Now my dear friends, again we can divide it by 2, so we get yes. So now my dear friends, now again we have to reduce it into the simplest form. So now my dear friends, this will be cancelled by 3. How many times? It can be cancelled by 172 times, and it will be cancelled by 3. How many times? It will be cancelled 165. So okay, so here we get 172 upon 165. So now if you observe this, we get x is equals to 172 upon 165. So this is what? This is the answer. Okay, I hope you understand these things. Yes, so now let's do some problems. Okay, now write the following in decimal form and say what kind of decimal expansion each has. Okay, so now my dear friends, we have to convert it into the decimal form, and we have to tell that what kind of decimal expansion is there. Okay, yes. So now my dear friends, if we divide 36 by 100, we get, now here is dividend is less than divisor, so we are taking 0 point, here is 0. Okay, so 100 is 300, so we get 60, here is 0. So 100 is 600. So this will be cancelled. So my dear friends, here is remainder becomes 0. So we get my dear friend 36 upon 100 is equals to 0.36. So this is what? This is my dear friend, this is terminating decimal. This is terminating decimal. Because in this case remainder becomes 0. Now let's move to the next question. Yes, so now my dear friends, so the next question is 1 upon 11. So in this case my dear friends, we have to divide 1 by 11. Okay, now again here is dividend is less than the divisor, so we have to put the point and we have to take 0. Okay, so now again this is again less than from 11, so we get again 0 here is, and here is 0, so we get 100. Okay, now 11 9s are 99. If we subtract it we get 1. Okay, this is 0. Now again we have to take 0, and here is also 0. So again this will get by 99, this will get by 9, so we get 99, which is divided, which is if we subtracted this we get 1. And similarly and so on, this will be steps will keep on. Okay, so now so we have 1 upon 11 is equals to 0.09090909 and so on. So we can write it as like 0.09 bar, 0.09 bar. So this is what? This is my dear friends, this is non-terminating and repeating, non-terminating and repeating. Here is, this is non-terminating but this is repeating. Okay, I hope you get this point. So now the next question is 3 upon 13. Okay, here is 3 and here is 13. Now take the point, take the 0, so we get 13 to the 26, so we get 4. Here is 0. 13 3s are 39, so we have 1 0. Okay, now we have to take again 0, so after placing the here 0, so now we can take the here 0. Okay, so my dear friends, we get 13 7s are 91, so we get 9. Okay, and again 0, so my dear friends, we get 13 6 are 78, so we get, my dear friend, here is, yeah, here is 12. Okay, now here is 0, so we get, my dear friends, 13 9s are 117, so we get 3. So now this becomes our first step. Okay, here is 30 and here is 30, so now the next step will be repeating. Okay, so my dear friends, we get 3 upon 13 is equals to 0.230769 bar. Okay, after this is repeating. Okay, so now my dear friends, this is what? This is non-terminating and repeating, non-terminating and repeating. Okay, my dear friends, I hope you get this point. So now, my dear friend, these questions are very easy. Just we have to understand the concept of the question. Okay, so now, my dear friends, so the next question is, we have 1 upon 7 is equals to 0.142857 bar. Okay, here is bar. So now, my dear friends, can you predict what the decimal expansion of 2 upon 7, 3 upon 7, 4 upon 7, 5 upon 7 and 6 upon 7? We have to find the decimal expansion of this. Okay, so now how we can find it? And we have to find without doing the long division method. Okay, so now, my dear friends, we know that 1 upon 7 is equals to 0.142857 bar, 57 bar. So now we can write here like this: 2 upon 7 is equals to 2 into 1 upon 7. Okay, which is equals to 2 into 0.142857. If we multiply with this number, we get 0.285714. 0.285714. Now again we have 3 upon 7, so we can write it as 3 into 1 upon 7. So we get 3 into 0 point, here is bar, 3 into 0.142857 bar. So we get, my dear friends, 0.428571 bar. Okay, now we have to find for 4 upon 7. Okay, so for this, 4 into 1 upon 7, which is equals to 4 into 0.142857 bar, which is equals to, my dear friends, 0.571428 bar. Okay, now what is the value of 5 upon 7? Means 5 into 1 upon 7, which is equals to 5 into 0.142857 bar. So this will be 0.714285 bar. Okay, now 6 upon 7 is equals to 6 into 1 upon 7, which is equals to 6 into 0.142857 bar. So this will become 0.857142 bar. So my dear friends, I hope you understand these things. Yes, so now my dear friends, so the next question is, express the following in the form of P upon Q, where P and Q are integers and Q is not equals to 0. So now my dear friend, first question is 0.6 bar. Okay, first question is what? 0.6 bar. So now let x is equals to 0.6 bar. We have to convert it into the form of P upon Q. Okay, this is our first equation. Okay, now we have to find the number of terms which are repeating after the decimal. So how many terms? This is only just one term, because we can write 0.6 bar is 0.6666 and so on. I hope you understand these things. So now we have to multiply 10 in equation 1. So we get x is equals to 0.6 bar into 10, which is equals to, my dear friends, 10x is equals to 6.6 bar. 6.6 bar. Okay, my dear friends, I hope you understand these things. So this is our equation number second. So now, my dear friends, we have to subtract equation 1 and equation second. So we get, if we subtract it, we have to subtract equation first from equation second. So my dear friends, this will become, here is 10x minus x is equals to 6.6 bar minus 0.6 bar. Now if we subtract this, we get 9x is equals to, here is what? Here is 6. Okay, so now we get x is equals to 6 upon 9, and we have to reduce it into the simplest form. So my dear friends, we get, here is 2 and here is 3. So we have 2 upon 3. So x is equals to 2 upon 3, which is in the form of P upon Q. Which is in the form of what? P upon Q. So this is our required answer. Okay. Yes. Yes. So the next question is, my dear friends, we have 0.001 bar. 0.001 bar. Okay. So first of all, let x is equals to 0.001 bar. Okay. So this is our first equation. So now, after the decimal point, we have 3 digits which are repeating, which are recurring. Okay. So now we have to multiply. We have to multiply 1000, because three digits are repeating. We have to multiply 1000 in equation 1. So we get 1000x is equals to 1000x is equals to 1.001001 and so on. So this will become 1000x is equals to 1.001 bar. So this is our second equation. This is our what? This is our second equation. Yes. So now subtract equation first from equation second. Okay. So we get, my dear friends, 1000x minus x is equals to 1.001 bar minus 0.001 bar. So this will give, my dear friends, here is 999 x is equals to 1, which is equals to x is equals to 1 upon 999. 1 upon 999. So this is our required answer. So I hope, my dear friend, you understand these things. So now, yes, so the next question is, my dear friends, we have to express 0.9999 and so on in the form of P upon Q. Yes, my dear friends. So the first step is that we have to let x is equals to 0.9999 and so on. So we can write it as like 0.9 bar. 0.9 bar. So this is our first equation. Now in the second equation, here is, we have to find how many numbers are recurring after the decimal point. Only just one. So we have to multiply 10 in equation 1. Okay, so this will become 10x is equals to 9.9 bar. 10x is equals to 9.9 bar, because if we multiply in this equation 10, okay, so this decimal point will shift to one digit because we have to multiply with the 10. Okay, yes, I hope you understand these things. So now, my dear friend, this is equation second, and we have to subtract second minus 1. So we get 10x minus x is equals to 9.9 bar minus 0.9 bar. Okay, so this will become 9x is equals to 9. 9x is equals to 9. So we get, here is x is equals to 1. So my dear friend, this is the answer of this question 1. 1 is the answer. I hope, my dear friend, you understand these things. So now let's move on to the next question, which is, write three numbers whose decimal expansions are non-terminating, non-recurring. Okay, we have to write three numbers which are non-terminating and non-repeating. So what are these? Let's write that. First example is root 3. First example is what? Root 3. Okay, so now, my dear friends, if we write the value of root 3, this is 1.73205 0807568 and so on. Means it is not terminating and not repeating, non-recurring. Okay, now second example is under root 26. Okay, if we see the value of under root 26, this is 5.09901951392 and so on. Okay, again this is non-terminating and non-recurring. Now let's see the third example. Like, third example is under root 101. If we see the decimal expansion of this number, we get 10.049875621112 and so on. Okay, so my dear friends, I hope you understand these things. So my dear friends, so the next question is, find three different irrational numbers between the rational numbers 5 upon 7 and 9 upon 11. Okay, so now, my dear friends, we have to find three different irrational numbers. So first of all, we have to convert it into the decimal form. Okay, so 5 upon 7, if you convert it into the decimal form, we get 0.714285 bar. This is not terminating but repeating after the 5. Okay, now decimal expansion of 9 upon 11, which is equals to 0.81 bar. Okay, so the rational number, these are the rational number. Okay, so now my dear friends, we have to find the different irrational number, 3 different irrational number. So between these two numbers, okay, so these are, so 3 different irrational number are, which is equals to, my dear friend, this will become, first is 0.7 307 3007 30007 3000073, and we can write it like this. Second example is 0.75 075 0075 00075, okay, and 000075, so and so on. Third example, my dear friends, we can write it as like 0.76 076 0076 00076 000076, and we can again 5 times 0 76, 6 times 0 76, we can write it as like this. Okay, so this is the what, this is the 3 different rational irrational numbers. Okay, I hope my dear friend you understand these things. So now my dear friend, this is enough for today, and we will meet in the next lecture with the next amazing topic. So thank you very much for listening me, and take care and goodbye.